Welcome to our group project presentation on mechanism Sessional tutorial 5. My name is K-arantodu Sindhu and my roll number is 22MF1008. I am third year and a graduate student from Mechanical Department at IIT Kharagpur. Me and my teammates N-ikkula Krishna Karthik 22MF10028 and K-uruva Priya 22ME30036. Let's begin with the product information. Product information contains technique, mechanical challenge, chain system, model synthesis, dynamic simulation, simulator mechanics, mechanization and human intervention. 6 and 4 bar linkage. Advantages, disadvantages. No. Technical challenges. Design and simulate a garage door mechanism with these constraints. No primitive higher kinematic pairs. This means the mechanism should avoid sliding joints like those in traditional garage door and other complex joint types. Space efficient open position. The door should occupy less space when open. Motorization with manual or override. The mechanism should be capable of both motorization and manual operation. Joint system. The 4-bar linkage, also called a 4-bar. This is the simplest closest chain movable linkage. It consists of 4 bodies called bars or links connected in a loop by 4 joints. The last link is a floating link, which is also a couple or connecting rod because it connects an input to the output. 4-hour linkage have 4 rotating joints. One link of the joint is usually fixed and is called the ground link. Fixed link or the frame. The 2 links connected to the frame are called the grounded links, are generally the input and output links of the system. The last link is floating link, which is also a coupler or connecting rod because it connects in the input to output. The first closed chain movable linkage. It is used by us for garage door mechanism because a 4-hour linkage consists of 4 rigid links connected by rayot joints, forming a closed loop. This configuration allows for conventional of rotation motion to linear motion, transfer of force and motion between links, control of movement, and chain linkage is the simplest closest chain movable linkage. It is used by us for the garage door mechanism because the 4-hour linkage consists of 4 rigid links connected by rayot joints, formal closed loop. This configuration allows for conventional of rotation motion to linear motion, transfer of force and motion between links, control of movement and positioning. The garage door could be made using a 6-bar linkage mechanism, but the synthesis of the such mechanism is carried out through multi-stage synthesis, which is complex process, whereas the synthesis of 4-hour chain is straightforward and could serve the same purpose. However, through 6-bar linkage carrier, moreover, through
Krishna Karthik, this is SolidWorks. Let's start with synthesis. The process we are taking is a 3-position synthesis. For 3-position synthesis, we need 3 configuration of the garage door. The 2 configurations were obviously open and the closed configuration, and the third one, which was the intermediate configuration, will be taken arbitrarily by our own need. And we make a nomenclature of A1, A2, A3, B1, B2, B3 for the different positions of the garage door. And step 1 was to roughly draw of same length of the coupler A1, B1, A2, B2 and A3, B3. On step 2 we join A1, A2, A2, A3 and vice versa as B1, B2, B2, B3. We make a perpendicular bisector from A1 and A2 and A2 and A3 which meet at O2 and perpendicular bisector from B1, B2 and B2, B3, which intersect at O4. Those are our grounds, and the coupler, as you can see here, is the final door mechanism. And next I'll show you the simulation video. As you can see, the simulation covers all three positions of the garage door. Next we move to, this was a simple 2D linkage software of the garage door, which obviously like simply a 4-bar mechanism. Next we go to the model synthesis. Mechanical integration of a 4-bar linkage system involves combination of components to form functional mechanism, connecting the links to form a closed loop and a fixed base for a secure mechanism, and it acquires flexible body integration. The garage door sticks flat on the ceiling, and the close and opening of the doors should not tend to move above the ceiling, which are the constraints which we got in this problem. This was our SolidWorks model garage door. We have taken coupler of a 4-bar chain to where our garage door horizontally and vertically positions through the with respect to ground. And let's go to the simulation part. This was the garage door we made using SolidWorks, and as you can see, and all 4 different positions. Okay, now from here on my friend Haripriya will take the lead.
My name is Priya Kurva, and let's go with simulator mechanics, mechanization and human intervention. When the switch is turned on, the input rotates due to the motor under the influence of gears and slowly rises till the horizontal position due to the action of electromagnet on the ceiling. The electromagnet holds the door open till the switch is on. The moment the switch is turned off, the electromagnet shuts down, and due to the influence of gravity, the door gradually closes back to its vertical position. For automation, we can use gears, motors, and electromagnets. We can attach an electrically powered motor to the input link. Using gears, we can achieve the required speed with which the garage door moves or revolute joint rotates. We can have strong electromagnets in the top position. Now, advantages of 4R linkage: simple and robust design, efficient force transformation, compact and space saving, adjustable and adaptable to various door sizes and types. Though 4R linkages are cheaper to manufacture and could serve the purpose, 6R linkages could be a better choice in some cases. Cases where the available space is less, a 6R linkage is better suited, as in a 6R linkage for the same rotation of input link, the vertical height achieved can be higher. In other words, for the same configurations, the ground hinges would be closer to the door, making it more space efficient. Thanks for sticking with us.